Hello and welcome to your third instructional physics class. I am Mr. Marcus, your summer school online teacher, and today we're going to talk a little bit about acceleration. Now in our previous video, we spoke about velocity, and in layman's term, we define velocity as the change in position over the change in time. Where velocity, and we've only spoken about velocity in four basic planes: north, south, west, and east. We said that basically the velocity is the change in position of an object, over the change in time. And we said that the average velocity can be defined as change in x over change in time, which basically can be translated into the final velocity, final position, over initial minus initial position over final time minus initial time, right? And in our previous example, we worked with that, and we stated that, for example, when working with velocity, the direction that the object was moving would determine the sign of the value, whether it was positive, negative, and that depends. If it was moving upward, or northward, the object motion is positive. If it was westward, it was negative. If it was south, it was negative, and if it was east, it was positive. So today we're going to continue with this similar train of thought, but we're actually talking about acceleration. Now we can define acceleration as basically the change in velocity of an object. Now we're still working with one dimension, which means we're not seeing any vectorial motion like northeast or southeast or anything like that. And we can define acceleration, like I said, as the rate of change in velocity, and it's actually given to us by the formula. Average acceleration equals the change in velocity over the change in time, which can actually be expressed as the final velocity minus the initial velocity over the final time minus the initial time. Now I want to point something out that I didn't point out in the previous video. Whenever we're working with time or solving for time or using time in any capacity, the variable of time must be positive. Time cannot be negative, and that's a whole big, although a lot of physicists, and modern studies are trying to prove that's not true, but the reason why time can't be negative is because according to many theories in physics, time moves forward, not backwards. So time will never be negative unless of course that's ever proven. We never know. Okay, so what I'm going to do is I'm going to go over this quick example with you guys, and then when you're done watching this video, I'm going to direct you to page 47, where you're going to answer problems 1 through 4. So the example says, a shuttle bus with an average acceleration of negative 1.8 meters per second. How long does it take the bus to slow down to a complete stop from a velocity of 9 meters per second? So we have a bus that has an acceleration of negative 1.8 meters per second squared. Now the negative in this case does not refer to the direction. It actually refers to the fact that it's slowing down. Now in an acceleration, when accelerations are negative, it just means that it's slowing down. So it says that the bus has a negative acceleration of 1.8 meters per second squared, and they want to know how long is it going to take the bus to stop from 9 meters per second to 0, right, or to a complete stop. So whenever you hear a complete stop, a complete halt, or whenever you're working with, or if it says to rest, all that means that it's going to be 0. If the problem says something like starts at rest, or the initial velocity is 0, all those things can vary. So what you want to do in this exercise is just write down the variables that you do have. We have our average acceleration, which is negative 1.8 meters per second squared. We have our final velocity, actually, which is 9 meters per second, because the problem is saying that it's going to go to a complete stop, which means our initial velocity, is 9 meters per second. And since it's going to go to a complete stop, that means that our final velocity is going to be 0. And we are looking for our change in time. Okay, so again, the variables that we do have given to us in the problem are the average acceleration, which is negative 1.8 meters per second. The final velocity, which is 9 meters per second, the initial velocity, which is 9 meters per second, and our final velocity, which is 0 because it's coming to a complete stop, and our change in time is the variable that we're going to Okay, so once again, our average acceleration is negative 1.8 meters per second squared. Our final initial velocity is 9. Our final velocity is 0 because it's coming to a complete stop, and the variable that we're looking for is time. So how do we work with the variables? I'm actually going to use this side of the board to plug everything in. So instead of using my average acceleration, I'll say that that's negative 1.8 meters per second squared. Instead of writing final velocity, I'm going to say that my final velocity is 0 because it comes to a complete stop. My initial velocity is 9, and the change in time is the variable that I'm looking for. So I'm going to leave negative 1.8 meters per second squared expressed. I'm actually going to subtract 0 minus 9, which is negative 9, and all that over my change in time. Now I have to isolate for the change in time, which means I'm going to multiply everything by change in time. This is going to cancel out, and I have negative 1.8 meters per second squared equals, or change in time, excuse me, equals negative 9. So what I'm going to do now is divide everything by negative 1.8. So negative 1.8 and negative 1.8. And this is all going to cancel out, right? And of course this is meters per second. So what I'm going to do now is just divide, and I'm going to finish it here, divide negative 9 by 1.8. Now you can use a calculator, or if you're good at remembering your decimal rules, the answer for that would be that the change in time is 5. But remember, meters per second cancels out with meters per second, and since this is seconds squared, my answer is 5 seconds. So it takes 5 seconds for the bus to reach a complete stop, okay? So this is it for this video lesson. This problem is really easy to work with. What you're going to do now is when you're done watching this video and reviewing everything, you're going to go to page 47 of your textbook, and you're going to answer problems 1 through 4, and that's it for this instructional video class. I will see you soon. This is your favorite physics teacher.